right, ladies and gentlemen, it is time for a warm-up. So everybody should have out their whiteboards and their expo markers. If you don't have an expo marker, this time and this time only, I will let you borrow one. If you are in H block, Patterson and Elizabeth are going to be stopping the video to let you guys answer your question, and they're going to be kind of checking you. This should be pretty fast-paced. If you're in G block, that's Jackson's job. So let's get started. So first thing is graph y equals cosine x. And I would like your independent variable, your x-axis, units in degrees. Okay, ready, set, go. You should have like 30 seconds to do this. Okay, and the answer is, here is your coordinate plane. Remember that cosine comes from the unit circle. You don't have to graph every single point like you did on your pasta things. You can just graph the four corners. So this is 0. The point there is 1, 0. Here we've got 0, 1, negative 1, 0, and then 0, negative 1. So for cosine, we're talking about the x value. So at 0 degrees, cosine equals 1. Then we're going to go up to 90 degrees. Oops, 90 degrees goes to 0. At 180, cosine is negative 1. At 270, cosine is 0. And at 360 degrees, cosine is positive 1. And you can connect, do the negative direction, negative 90, negative 180, negative 270, negative 360, plot, and connect. And there we go. There is cosine of x. Okay, so that's in degrees. Erase your boards. Boards should all be erased. So again, I want you guys to graph y equals cosine of x. I want your units in degrees. Okay, your independent variable units. Got less time now, 15 seconds. It should be quick. Okay, and your answer is this exact same graph again. Okay? If you have questions, talk amongst yourself, ask each other, get them figured out. Next question. Same thing, y equals cosine x. This time I want you to do it in radians. Okay, pause the video, give you guys a second to do it. All right, solution. So now you're in radians. So instead of going by 90, you're going by pi over 2. So 1 pi over 2, 2 pi over 2, which is just pi, 3 pi over 2, 4 pi over 2, which is 2 pi. And now you're working in the negative direction. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Plot your points, positive 1, negative 1. Same exact graph as before, just different units on your x-axis. Connect. Make sure you guys are connecting with a smooth curve. These aren't pointy, jagged graphs. All right, so there's your cosine x in radians. Next, I would like you guys to graph y equals sine x. How about let's do your units in degrees. Pause the video, give you a second to work it out. Okay, answer should be y equals sine x. We're doing degrees. So 90 degrees, 180 degrees, 270, 360. I'm just going to do my positives. Negative 1. Okay, at 0, if you look back on your graph here, sine is 0. Then it goes to 1, 0, and then to negative 1. So remember thinking about your unit circle, because that's where you get your points from. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Sine is 0, and at 90 degrees, sine is 1. At 180, sine is 0. 270, sine is -1. And at 360, it is 0 again. Okay, remember we said that you start going up the roller coaster first with sine. Okay, next, y equals, let's do y equals cosine x in radians. Okay, radians. Ready, set, go. Pause the video. Okay, and your answer should look like this. You guys should be doing this really quickly now. Next question. Let's do y equals, now we're going to switch it up a little bit. We're going to do y equals negative sine of x. Okay, y equals negative sine of x. So think back to algebra 2. What happens when you have a negative in front of your function? Okay, you guys should be thinking. A negative in front of your function should reflect all of your points down across the x-axis. So if it was at +1, now that point's at -1, and so on. So go ahead and pause the video, graph. Okay, and your answer should look like this. I'm going to do this in degrees. So 90 degrees, 180 degrees, 270 degrees, 360 degrees. And I'll do some of the negative values too. -90, -180. Okay, normally sine starts at 0. So sine of 0 is 0. If you put a negative in front, it stays 0. When you get to 90, sine of 90 is normally 1, but this time it's going to be -1 because of the negative out front. It's flipped it. So all of your points will have reflected. And so it looks something like this. So instead of going up first, you're going down first. So remember, this is what sine looks like when it's regular sine. If you think about the roller coaster thing, right, when you're riding the roller coaster, you go up the roller coaster first for sine. Well, for negative sine, you're going to go down the roller coaster first. Okay, so you guys try y equals negative cosine of x, and do your independent variable units, let's do them in radians. So pause, give you guys a second to think. Okay, and the answer is pi over 2, pi, 3 pi over 2, 2 pi, we'll do some negatives, negative pi over 2, negative pi. So now cosine normally starts at +1. So instead of starting at +1, because it's negative cosine, it's going to be reflected down. It's going to start at -1. Then go up to 2 pi, +1, and so on. And remember to connect with a smooth curve, not pointy, like sharp mountain things. All right, and that's negative cosine of x. Next question. What is the period of cosine? What is the period of cosine? Answer, answer, answer. Shout it out if you know it. It is 360 degrees or 2 pi radians. Remember, that's the time it takes for this function to complete one full cycle. We start at the bottom, 0, top, 0, back to the bottom. Look, that's 2 pi radians, or 360 degrees. Same thing for sine. Sine, start at 0, up to the top, middle, down to the bottom, back to the middle, one full cycle, 360 degrees. Okay, so what is the period? Everybody, shout it out. I know some of you guys aren't shouting. What is the period of sine and cosine? 360 or 2 pi radians. Say it again. What is the period? What is the period? 360 or 2 pi radians. Okay, next question. So that's the period of the function. What is the amplitude? What what is the amplitude of sine and the amplitude of cosine? Okay, if you know it, write it down, hold it up on your board. And the answer is 1. The amplitude is 1. Remember that that is the distance from the midline to the top of the function or the midline to the bottom of that function. It is 1 unit. 1 unit. That is the amplitude. So everybody, again, what is the amplitude of sine or the amplitude of cosine? 1. What is the period? 360 degrees or 2 pi radians. Okay? So that's your warm-up. I hope everybody feels comfortable with graphing sine and cosine. The stuff that you guys are going to do in class today is going to be very difficult if you don't have a good understanding of what sine and cosine look like. So if you're still stuck, ask a question, go see Mr. Taylor. Good luck.